So my point, O2 is oxygen, right? But with that third oxygen atom on there, this is the ozone. We're all familiar with the ozone. How many knew it looked like this? Well, when this is floating out there, it's so fun because you get the biggest kid, right? And he comes up and he punches it. I use Scotch tape, but with the Velcro, he'll punch it really hard, but it'll just vibrate, and it won't dissociate. But then the little girl will get up and she'll hit it with just the right, or little boy, politically incorrect here. So when they punch it, this is exactly what happens. HV, your ultraviolet comes in, bam, you got the O2 and a radical, right? So that's why this was floating to be really good now. And what I found is the kids then all of a sudden are in the reaction vessel. When these molecules, because I'm going to show you another one here. H2, like I was saying, right? If you took two H2s and an O2, what does that make?
Water.
Balanced equation, how many waters? Twice as, when this is visual, I'm not going to waste my balloons here, but if I have two H2s and one O2, this is a space shuttle, right? You got your big orange tank there. One of those is twice as big as the other. I've done this a while, now I'm confused. I know it's backwards, that the oxygen actually goes to the top. Oxygen is more dense. You think that they would want to save the energy of pumping it up that high, but it actually, they use gravity to let the O2 go down. So the smaller one is up top. The one that's twice as big is down below. So that is the LH2, they call it. I do a lot of space science stuff. And LOX, LOX, liquid oxygen, right? This is the most fundamental reaction there is. The most heat liberating. That's why they still use it. H2O2. Thank Robert Goddard. So when you get these guys together as a liquid, they release energy, they make water, which now really looks like Mickey Mouse. And again, what it is it's a vapor, so it's a gas when it comes out because it's really hot, right? So when the kids are visualizing this, you're in it, it gets in the brain. There's no way that you have to memorize it or make it a learning thing. It's just in there. So what I do is I develop ways of teaching, and I have all these other balloon molecules, color coordinated. I mean, look at that. What's positive? I still see books that do this backwards. Red should always be positive. Goes back to Ben Franklin. This is why charge goes one way and electrons the other. It's confusing in physics. Red is positive. Electrons are going to be green, negative. So if you stick with that color code, it works all the way through. That's water. Do you know how water sticks together? The plus is, they're just protons out there, right? These electron pairs, this is what I found the next key was. After your simple hydrogen, this octet of electrons is what the periodic table's form is all about. So here I'm at College of Marine. You guys are in a very historical place. I don't know if you know the history of Cal Berkeley. Have you ever heard of G.N. Lewis? I'm a non-traditional student, right? So all of a sudden I'm like going up to Glenn Seaborg. I just see him on a video and I'm like, they interviewed him, he goes, well, you know, I thought this column should be taken out and put down at the bottom, and all my colleagues said, don't do it, it'll ruin your career. And he goes, what career? And he did it, you know, and I'm like, this guy's cool. So I go and I introduce myself, and I meet him, and you start talking and you pick up stories. So G.N. Lewis is the one that came up with the octet of valence electrons. Valence means the outermost, right? So the whole theme of covalent bonding with the octet, G.N. Lewis, 1916. Got credit for her? I'll give you a little history. The Russian got it for ionic. He came up with kind of the same time. But this 8 is the predominant theme. Well, what is 8? It's a stop sign. So what I tell kids, when you're doing the electron octet, you stop at 8, right? So, G.N. Lewis, is there a building for him out there?
Yep.
What was it?
Lewis Hall.
No, for him. That was after. See, they always build it after.
Oh, right.
Gilman Hall, they built for Lewis. Lewis says, I'm not coming to Cal unless you build me a lab. So the history part I'm getting to is Gilman Hall, which is now tiny. On the 3rd floor, G.N. Lewis was Glenn Seaborg's research advisor. So here's Seaborg, you know, all this water, stuff that I love, aqueous chemistry, and Seaborg goes, all these people go, what's your name doing on all this aqueous chemistry stuff? Because his early papers were with Lewis. That was his research advisor. Well, after Lewis, who was the next big guy at Cal? This is why I learned the history. I was at Borders. You guys got good. I'm from Santa Maria down there now, Pismo Beach. We don't have Borders or Barnes and Nobles. The science section, the history of the making of the atomic bomb, the Richard Rhodes. You ever seen that? I could blab all day. I know this guy from England. He publishes all the Scientific American articles on periodic table. He doesn't know half of what I know, and I got it all from that book. Look in the back and start looking up Glenn Seaborg. Don't try and read the book cover to cover because it's thick, right? And you'll see G.N. Lewis, research advisor for Seaborg. Seaborg carried over Macmillan's work, who was working with Lawrence. You heard the Lawrence Berkeley Labs? Ernest Orlando Lawrence. You know where he was from? I love the story. He sold pots and pans door to door in South Dakota to get money to go to college. And he ended up becoming, I think, almost a Rhodes Scholar. He ended up at Oxford and all that. But he invented the cyclotron, which is like, you think the Newton Renaissance was big? Cal Berkeley, this was big stuff. And they couldn't release the information, so it's not as popularized as you would think. But on the hill out there was lots of history. The other one, have you ever heard of Harold Urey? See, I always look for inspiration. He discovered deuterium, and he was in on the Stanley Miller one where they took the H2 ammonia and all those and made an amino acid. You know that famous experiment in the test tube thing? Harold Urey slept in a tent for 2 years outside the University of Montana because he didn't have money for rent. He figured, well, I'm doing all this research anyway, you know. So these guys, you know, worked their butts off. Everybody thinks when you get a Nobel Prize, like, oh, they had this prestigious life and all that. So my other point is the Cal Berkeley tie. You had Ernest Orlando Lawrence from South Dakota. G.N. Lewis grew up in Nebraska. And then right next door, have you ever heard of one of my sweetest little ladies, Darleane Hoffmann? We call her modern day Marie Curie. She's still alive. I'll tell you, if you could call her on the phone and she'll take your call and she'll probably come out and talk to your kids. That's how sweet a lady she is.
Wonderful.
She's been emeritus. She's been trying to retire. She was the head of the Los Alamos lab in 1957 with 2 kids and a husband. Everything they said women in science couldn't do. Well, she's been doing it for years. Her, Al Ghioroso, and Glenn Seaborg are the trans-uranium people, they call it. All those elements. So she was in on it. She's from Iowa. So I'm looking right at the country, and I'm like, right out in the middle of nowhere, South Dakota, Nebraska, and Iowa, you've got a modern Glenn Seaborg. You know where he went to high school? I went and did a lecture at his old school. Southgate. Not even Watts. That's more dangerous than Watts. And those kids were nice, I'll tell you, man. They were real polite. Crips and Bloods. Crips and Bloods.
He invited them to autograph your car.
I have this gets off the subject, but I have a 69 Fairlane that I did a poster of the elements to make it look cool. See how the elements encircle the earth, you know? So I had this old car I paid $75 for, 25 years, got me through Sonoma State and college where you're driving around. Put 100,000 miles, 120,000 on a $75 car. So what was I going to do with it? I painted the elements on it. This is back in '97. Right when they named the element Seaborgium, he gives a talk at College of Marin, and my physics professor is driving him home. So I said, Dr. Peterson, you know, let's see if we can get him to sign the car. So I'll never forget that I almost missed it because I was looking for a camera. You know, you never get pictures and stuff. So they were taking off, and I raced over. I blocked them in. I ran up to the window. I said, you know, can you sign my car, Dr. Seaborg? And Peterson goes, oh, Glenn, you got to sign this, right? I'll never forget. Glenn was like real big. He's 87 already, you know, all this arthritis. He gets out, he sees the car. It's all the elements all over the car. And he goes, oh my God. So he signed the car. I took the car to Watts after Glenn died a couple years after that and went into Southgate and did a free lecture for the kids. And when I wasn't looking, nobody was watching the car, we pulled it in on campus. Because I let kids sign it. It started with their initials underneath, you know, the thing, and then it got to the point where, you know, pick an element and sign it, because I give them ink that I know would fade, you know. Well, I came out, and these guys